Namaste, good day to all my students. In this lecture, I will explain about business case for IP. This is the first topic in the module 3. Here what it is explaining is this particular line. It is a thing explanation. You just think that thing is anything. I will take the example of my pen. That this pen, it is connected with internet, right? When it is connected with internet, and daily I am using this particular pen, and I want to know that daily how much ink I am going to utilize. That particular thing I want to store in some place I can store in a data center. I can think that it is a machine having high processing speed. I will take a simple example is I can store in my laptop only. Otherwise, I can store that particular data in cloud, right? How much ink it is utilizing. What is the use of that one? Once the ink is going to end, I can bring one new refill and I can fill into this particular pen. And that particular data, how can be stored? Two ways, centralized way. Centralized means that particular data, for example, now it is 100%. 100% is stored in one place, it is called as centralized. 100% is storing in more than one place, it is called as distributed. What is the advantages of distributed? Because one place the data it is lost, I can get it from the other place. That is the advantage. Next thing, here that particular data want to access by multiple people. For example, some 50 people want to access, I can go with a traditional operating system and I can make it as a server and people can access only 50. And that same time only one just I am thinking it's an example only. One operating system can access 50 people means traditional operating system I can provide. What is traditional? What operating system we can use? Like a Windows server. These all are server operating systems that I can use and I can serve 50 people. And immediately some 100 people are coming. One traditional operating system cannot able to serve it. Then I have to go with virtualization technique. What is virtualization? Multiple operating system can be executed simultaneously. Can be executed. That means instead of one traditional operating system, two traditional operating system, it is going to execute it in a single system. Then 50 for one operating system, second operating system, next to 50. 100 people I can serve. That is called as virtualization. Virtualization in the last module I explained clearly. I hope you understood there also. Now this communication between these IoT devices, it should be some lightweight application. Already I explained in the previous video also. IP is a bulky protocol. We have to optimize it and we have to enhance it, make it as a compact or more small. Then only we can use for the IoT environment. And next one we will see the first question here in the module 3. Explain the key advantages of IP suite. Here some basic knowledge it is going to give here. One is IT. IT is what we are going to use currently here. It is IT industry. And what is our aim of OT industry? What is OT? Operational technology. That means the industrial machines have to be worked automatically without or less help of the human beings. That is called as operational technology. Here you see here. What is the mission of the vendors or the producers? Their mission is to work automatically by the machines, but it cannot be able to implement immediately. It should be happening in a incremental step. One by one step only it can be implemented, because it is not a very simple concept. Already I discussed here 30 years back only IP architecture or IP is made. Now IP it is using by 3 billion users. That IP only we have to modify and we have to use for the IoT environment. This is the answer of the key advantage. First one is open and standard based. All the vendors means who are the producers, vendors have to be optimize the communication. Communication means all the protocol which is currently using, which can be used for the IoT have to be optimized. Have to be optimized means have to be enhanced. In other terms, have to be make it as simple or small to be work for IoT environment. Right. Next one is in a IoT environment, there should be large set of devices. I will take one example again so that you will understand. For example, I took one machine having 10 crore rupees. Their IoT devices are there. They keep all the IoT devices from Cisco company. This is the thing I am explaining. Cisco company. After 10 years, one of the IoT device, it is died. It's not working. Maybe due to that one, the entire machine is not going to work automatically. What I can do, I can't throw that particular machine. It is 10 crore machine. Only 10 years I utilize. That is why I can replace that particular product, Cisco product. If it is possible, I can get the Cisco. Unfortunately, at that time, I am not getting the Cisco same product. I took from IBM company, same similar product from IBM company. I am going to place it. If I'm going to place it, it should work. That is, interchangeability have to be happen. It should work. It should not get a problem. It should have to work previously how it was worked. Same way it have to work. And security concern should not get. Previously, I have a high security because this everything it is connected with the internet. Anybody can attack your machine from the internet. That security concern have to be taken care, as well as management. What is management? Because for example, like that 10 crore 10 machines I took, we cannot able to manage easily. There should be some software or something should be there to manage this everything. That's why management also a matter. This all the things have to be taken care by the vendors who is producing this product, right? And they have to implementation, they have to taken care, validation, it is working fine or not, or deployment, they have to take. Deployment means keeping this particular machine into one place, it is working or not, and all the things should be based upon the standard base. There are different standard organization. One of the standard organization, it is IETF, Internet Engineering Task Force. They are the people who are having a rules and regulations to optimize the network layer concept as well as transport layer protocols. Network layer and transport layer protocol, they will make the standard. Based upon that one have to make. Mainly internet protocols should have to be modified. Their standard have to be seen from IETF, then have to be modified, because already we told that for the 30 years back we made the internet protocol suit that may not be possible or that may not be suitable for the IoT environment, and it have to update it. For that one, first we have to see the standards how it is done by IETF. Based upon that one have to do. Next one is versatile. What is versatile? Here, a lot of things will be there, because if you are thinking about IoT environment, lot of things or a lot of IoT devices will be there. It have to get the data, it have to be send the data, or it have to get the data from last mile. What is last mile? Very simple, is last kilometer. In the simple terms, if I am saying, the data have to be get from very far place. And very far place, data have to come very fastly, means bandwidth should be required. The bandwidth is more, data will come fast. Bandwidth is less, data will be coming very slow. That's why last mile what it is going to say. And one more technology what it is explaining here, it is backhaul network. What is backhaul network? Here backhaul what it is going to say here it is, for example, you generate your data in your home. You want to send some data. Now you are sitting in your home. From the data, that data it is going to the service provider, and each service provider having some strong backhaul networks will be there, or strong routers will be there. That routers will help to move the data from your place to the destination place, maybe cloud or maybe some other place. That are the backhaul links we will call. That backhaul links having good bandwidth, and it is going to transfer your data very fastly. And this communication mechanism it is explaining, it can be wired or it can be wireless. What is wired? Wire can be Ethernet technology, it is wire technology, or Wi-Fi. But in the case of IoT, Wi-Fi it is better. That only it is explaining. Here last 10 to 20 years, this OT technology that already I told operational technology, a industry is working automatically. It is made, and so many IP based protocols or so many other protocols which is more basic based on physical layer and data link layer is already made. That is the meaning of that one. IT is a long-term investment because already told 30 years back only we done IP. That time for making this IP, lot of efforts is required. Why? It is a basic protocol for sending the data. That's why lot of efforts, lot of investment, huge economical investment they done to build that IP, and immediately we cannot able to replace it. Mostly what we can do is we have to do the updation or optimization so that we can use in the IoT environment. And the third topic is it is ubiquitous. These are the points. First two points we already explained. Third point is ubiquitous. What is ubiquitous? Can see anywhere. Now nowadays we can see laptop or servers or everything mobile in anywhere. Like that, in future these IoT devices everywhere we can see, and we cannot able to use the operating system what we can currently using the Windows 7, Ubuntu, or not like that. We having lightweight operating system like Tiny OS, Contiki OS. A lot of things are there. Even though for the Raspberry Pi we having its own operating system, or different operating systems are there. Not all are lightweight operating system. That one we have to be used here. Next to this point, IoT application protocol in many industry OT solution have been updated in recently. Already I told OT so many protocols already it is made. Most of the protocols are based upon IPv6 because already I explained in the first video itself, because IoT is more supporting to the IPv6. That will be the better thing. That is why it is most of the protocol is based upon IPv6, and that and IP is a general protocol. Already with any form of data have to be sent. It can be video, it can be audio. That's why it is a general protocol. It is saying here. The fourth point is scalable. Already you know what is scalable. Now I connected 10 devices, means tomorrow maybe I want to connect more devices. It should be scalable. If that particular property should be there for the IPS, it is there. Millions of private and public IP infrastructure are there. Yes, not even public IP like internet. Private also we can make. A lot of things are there. This private and public, what are the things are there? This IP should be able to add the more number of devices. That's the meaning it is saying. And for that one, in the public or private environment, this optimization and design rules specified to a new devices. This optimization, because already private and public environment we are using different types of devices, but that particular technology we cannot able to adapt, or we cannot able to do directly into the IoT environment. We have to do some optimization. Otherwise, these lightweight devices cannot able to work. And this is saying about our not even IoT. It is saying about our current industry standard only. IT industry, we already made voice to send, video to send through IP. That only it is explaining. Due to all these things, which is helpful for the IoT environment also. Fifth point is manageable and high secure, because 30 years of back only already we explained this, everything it is done. We are currently using this one. So many security mechanisms we are adopted here. Already it is secure. And if you are trying to do some small optimization, we can easily to use in the OT environment. That optimizations and from the standard organization, what it is saying, based upon that one, if you are going to do, it will be better, because 30 years already we are using. Small modification if you are doing here network management issues or security issues management, means some problem is happening, immediately we will get to know, because that many softwares we having in the IP to help us to get to know all the details, as well as the security concern. Already it is implement a lot of algorithm for security. That's why small updations are there, we can able to use it. That's the meaning of manageable and high secure. Next one is stable and resilient. Stable and resilient. What is mean by that one? stable and resilient means it is not resilient, it is resilient. What I read was wrong, sorry. Stable and resilient. It is 30 years we done it, this one. Now we done this IP, it is used in financial, like banking sectors we are using, definitely defense we are using, and video and audio transferring we are using. We having huge security. These are all the things we have. That's why it is saying stable and resilient it is. That is why it is secure and safe. Very simple term if I am saying. That only it is going to explain here in stable and resilient. Okay. Next one is consumers market adoption. Here nowadays we are using smartphone, tablets, PC, and future we are going to use some other IoT devices to be able to see. That only it is saying consumer market adoption, because consumers what they want, based upon that one it have to make. Previously most of the people are bringing the laptop or desktop. Now most of the people want every facility in the smartphone only. That's why their consumer are the people, those who are bringing that one. Based upon that one market we have to see. Innovation factors, definitely we have to add more innovations into the IP, because we are using social network, mobility management, everything it is there here. These all the things you know, and more innovations have to be added to the IP to make use for the IoT environment. That only it is explaining here. And it should be flexible, that what are the things you are going to implement, because it have to execute in different small devices. These are all the things, and you have to be isolated, because two devices may be working together and some of the data have to be isolated. Like that, traffic have to be management, prioritization, different type of people are using the same network, and based on the priority it have to be given. For example, a military person as a normal person, it is using the same network, IoT network. The military person may be in their personal, not even personal message, it's defense related message, their message have to be go very fastly there. Prioritization we have to be implemented, like that. So many new things, this already prioritization are there in the current environment also. We have to be leverage, or we have to be optimize these all the things. That only it is explaining here. And there only one more topic will come, adaptation and adaptation. This already I told here, already I explained clearly in the first video. Please go through that particular video so that you will clearly understand here. Then also what they are saying is end-to-end communication. One end, now I am sitting in my home, I want to communicate with your people. One end is my home, another end is your home. That is end-to-end. Their last mile, maybe so many kilometers it will be there. There should be an important thing is a bandwidth. If bandwidth is less, maybe you are not able to hear it properly. There I can do adaptation or adaptation. Adaptation already I explained. What are the existing IPs there? Small modification have to be implemented in IoT environment. What is adaptation? Adaptation is nothing but a new IP we are implementing have to be put on the this particular devices. And even though the basically for the IoT so many new protocols are coming from the IT sectors, or maybe from the service provider sectors, X.25, X.75. So many things are coming nowadays. And you can see here, SNA, System Network Architecture, DEC Net, Digital Equipment Corporation, IPX, Inter-Network Package Exchange, Apple Talk. These all the things are coming here. Adaptation means application layer gateway, ALGs must be implemented to ensure the translation between non-IP and IP layer. Now, so many devices don't have IP. Pen, I took the example. This pen, normal pen, do not have an IP. We have to put some IP. How to put that IP? That everything we have to think it here. That only here it is saying in the adaptation. Adaptation in what is an existing IP? We have to do the modification and have to put adaptation. Adaptation means we do not want to worry. We have to make a new IP, have to be put in. And one more very important protocol here is SCADA, Supervisory Control and Data Acquisition. This is particular protocol is made for both adaptation and adaptation. Now we will think that why it is again done for adaptation, because new protocol it is done means we can do for new one, right? Then it can go for adaptation only. No. So that is the same example. I took a mission 10 crore only 10 years back. I cannot able to throw that particular mission. Now I am thinking that that mission have to be worked based upon current scenario, IoT environment, without the help of the people. There may be adaptation also required. Some of the protocol already it is made inside in that particular mission. There it have to be modified so that it can work with the current IoT environment. That is why both have to do adaptation as well as adaptation. That only it is explaining here. SCADA, both it is implemented. And there we can remotely monitoring already we told if human being is not required, from a far place we can monitor and we can control, we can switch on, we can switch off. Maybe the IP adoption model also, some Ethernet, maybe some wired technologies we may have to be uses Ethernet technology, or sometimes wired plus wireless we have to use, and maybe we have to forward the IPv4 traffic also. Maybe that is mission is maybe it may be supporting IPv4 only. That is why this all the things have to be taken care. That only it is saying in the case of SCADA. Next, the next question here, this also come under the first topic only, business IP. Explain the factors considered to determine select a model for last mile connectivity. For a last mile connectivity, already we told bandwidth is a matter. For that one, which is the best model we can select? There, first one is bidirectional versus unidirectional data flow. Because, for example, I want to communicate with your people. It is a bidirectional. There also IP is already satisfying. There we have to do the modification to optimize that only. In the last mile, very far place communication, or maybe unidirectional way have to be implemented. And for that particular application which is required, that only have to be put it. Unidirectionally is required. Now what I want unidirectional. I want to communicate with your people, but you should not want to communicate directly with me. That means it is unidirectional. Then unidirectional thing only in the IP I should implement, because more things are there. Again, it become a problem for my constrained devices. That is the thing. That only it is explaining here. For that one, we having LPWA, low power wide area technologies. We have so many protocols we have to take that particular protocol and we have to be implemented. In the case of, we have to be used bidirectional or unidirectional. Everything it is based upon the end-to-end architecture, because end-to-end means one end to other end. Next point is overhead for last mile communication path. Because you see, if you are using IPv4, because two ways mainly we are using IPv4 or V64 communication. IPv4 20 bytes of header, because header is a source address, destination address, everything will be CRC, everything will be there, but it is an extra burden for the data to carry. There is no doubt, it's a header. That's why 20 bytes. If you are going with IPv6, it is twice that one, 40 bytes header. Header means it is not your original data. Extra data you have to keep. 40 plus extra data is your data. 40 is just the header part. That is why it is a burden for sending that particular data for the network. IP, again, if you are sending, you have to send based upon IP TCP, IP UDP. IP itself, IPv4 it will take 20 bytes, V6 will take 40 bytes. In the case of UDP, IP plus UDP means IPv4 plus UDP means 20 plus 8, 28 it will take. For example, it is IPv4, IPv6 plus UDP means 40 plus 8, 48 it is going to take. And if it is TCP, you see it is very high, because what is the problem here is, here it is reliable and it is unreliable. That is why reliable means header size will be more. It is 20. If it is for IPv4 itself, 40 bytes. IPv4 plus TCP 40 bytes. IPv6 plus TCP it is 40 plus 20, 60 bytes extra in the network. It's become a burden. What are the things we can do here better to reduce this all the bytes, because this device cannot able to throw this 40 bytes at one time, because device is working based upon the battery power. These are all the things we have to think. Low power only, that's why we have to think. That only it is explaining here. this all the optimization technique we have to think it. That only it is explaining. Next is data flow model. IP adoption model is end-to-end. Already told adoption model end-to-end, starting to ending. We make the new IP to work it here. Security, privacy, everything have to be taken care. Data, normally data flow in a particular device is having two things. One is maybe unidirectional or maybe two directional, bi-directional. That is the thing here. Here, next thing, what is the thing? It is in the adoption model. Maybe we cannot able to use more applications. If you are using more application, again it is become a burden for that particular device. That only it is saying. Maximum 2 application servers or something we can use. Next one is network diversity. That is a very important thing. For example, what is it is explaining here? I took a Zigbee device. Using the Zigbee device, I am going to connect. Tomorrow, I want to use Zigbee device only. I am connected with the IoT devices. Tomorrow, Zigbee device, I replace some other device I kept here. This IoT device won't work. That should not be happening. Because any diversity in the network have to be kept. It should able to work. That work. But nowadays, it is not going to work because everything it is related. But that one, we have to try to make it out. ITU, you already know, International Telecom Union, the telecom standards are going to make this G3 PLC power line communication. Still power line communication also having the problem. What is power line communication? Smart grid. The internet electricity is connected with the internet and it is going to communicate. Already we discussed this all the things detailedly. And this optimization thing we will discuss in the next video. This is the end of the business one, first topic. I hope it is clear. Thank you. Thank you very much to all my students.